Okay, we just started talking about power series, and one application, one cool thing we can do with power series is we can actually find the sum of an infinite series that we probably wouldn't have thought of a way to find the sum of this without power series. This particular series, n squared over 3 to the n, would be a great candidate for the ratio test to show it converges. It's pretty easy to do that. To show that this sum converges to some finite number. But as we know, the ratio test only tells us if the series converges or diverges. If it converges, it doesn't tell us what it converges to, right? Some of our formulas do. The geometric series, we have a nice sum formula that will tell us what the sum is if it converges, but most of the tests don't actually give us the sum. So there's some clever ways of manipulating power series to actually find the sum. So here's how we're going to start this. Okay, we're going to take the geometric series. 1 plus x squared plus x cubed has an r value of x, and it can be expressed in very simple as just the summation from 0 to infinity of x to the n. And we know what that equals, right? In other words, what is the sum? First term over 1 minus r, right? We have that formula, a over 1 minus r. Okay, so, and we know also it converges if x is between -1 and 1. That's your r value. Now, we're going to take the derivative of this series of both sides. So we're going to take the derivative of the summation from 0 to infinity of x to the n, and we're going to take the derivative of what the sum is, what it equals. Okay, so now you can take the derivatives of series, it's with respect to x, and so just like you would if x was a number, you'd bring that power down and subtract 1. Okay, so that's the derivative of the left side. To take the derivative of the right side, you might want to think of this as 1 minus x to the -1 and do a chain rule. Don't forget the derivative of the inside, and that should leave you with 1 over the quantity 1 minus x squared. Okay, then we're going to multiply both sides by x. So if I multiply this one by x and this one by x, right side, now when you multiply the series by x to the n minus 1 times x to the 1, right, you would add those powers, that's just going to leave you with x to the n. And then I just brought the x over here. Okay. Next step. Now we're going to differentiate that series again, both sides. So the derivative of the left side, okay, we're going to bring that power down. Remember, n's a constant, so that'll be n squared x to the n minus 1. And the derivative of the right side, we're going to need a quotient rule. So you could run through that, simplify it down, and you should get to this. Now, we are going to re-index this. We can index this thing at 1 now. It was at 0 before, but notice if you plug in 0 for n, you're going to get 0 anyhow. So we might as well just re-index this to 1. Okay. The right side simplified to 1 plus x over the quantity 1 minus x cubed. Okay, we're almost there. Now we're going to multiply both sides by x. Again, this is the second time we've done that. And that's going to just give us, similar to the last time, that's going to give us just x to the n on the left side. And we'll just have an extra x there. Okay, now if you think about it, we are there. Our original series was n squared over 3 to the n. That's what we were trying to find the sum of, which is exactly what you would get if you substitute 1/3 in for x, right? 1/3 to the n is the same thing as just 1 to the n over 3 to the n, or just n squared over 3 to the n. Now, because these are equal, if I plug in 1/3 in for x on the right side, then I can actually figure the sum out. The sum of this series then, if you do all the math, gives you 3/2. Now, I would say this is definitely not intuitive. How are you going to know to take a geometric series and differentiate it twice and multiply by x? somebody else came up with that. That's a clever way to do it. But certainly if you were given the directions, right, step by step, take the series, take the derivative of it, multiply by x, I think that's something you should know how to do. And so now you know what we mean by taking the derivative of a series. And you can find the sum of this particular series. So there we go.